Our topic is artificial intelligence. We all know about this. We're primed to understand what is happening. You know, the end of the world is AI. That's a pun. I'm from London, and there's a part of London called Oxford Circus, and there used to be a guy for decades who had a sandwich board, and it said the end of the world is nigh. Eventually he died, ironically. I guess he was right, in a way, okay? So you see all these movies, and there are lots of them, right? More than we remember. We remember the last couple, but we've seen loads. And then you have, experts. Stephen Hawking, end of the human race. This is Elon Musk from Tesla and SpaceX. It's the demon that we are summoning. So these ideas are pervasive. And now we have the Internet of Things, which I will explain in a moment, proving that all this stuff is coming too, right? Well, the first thing to understand, let's just get a grip, shall we? The first thing to understand is these ideas are far from new. The word robot comes from a Czechoslovakian play in the 1920s, where these guys, robots, are helpful for a while, and then they take over the world and can't be stopped. And before that, this is the original art from Mary Shelley's Frankenstein. Frankenstein comes to life, cannot be controlled. And before that, in fact, for thousands of years, there's this idea which appears in the Bible. It's from Judaism, the golem, this clay figure that is animated, and again, cannot be controlled, wreaks destruction. So let's just put this into some historical context, okay? So up the top here we have the golem on the yellow timeline, and that's fiction, and what's going on in fiction. And on the other timelines, starting with the white one at the bottom here, we have what's going on in technology. And sort of the age of the golem was, say, from about 0 to about 1600. And what's going on in technology is the mechanical age. The Romans, for example, had a few water mills here and there. And a lot of that technology was somewhat lost with the end of the Roman Empire. But even when it existed, it was a bit like the mainframe computer of the 1950s. It was barely anywhere. There were a few special places that had it. But what happened during the following centuries was that watermill technology became ubiquitous. So by 1066, when there was a mass census in England, there were thousands, it was found, thousands of watermills. And watermills begat windmills, another powerful mechanical technology. So suddenly, people are seeing things moving by themselves, things that people have made that are moving by themselves. And that is why in 1600, we have this, again, fiction, Don Quixote. What does Don Quixote do? He sees 40 windmills on the horizon and thinks they are giants waving their arms and attacks them. So we start seeing the idea of automation and mechanization and the idea of the golem, the creature that we made that we can't control, merge. Now, what comes after windmills is steam, and what comes after steam is the automated loom, which again gets attacked. It gets attacked by real people called the Luddites, but they take their name from a fictional character, Ned Ludd, who is a machine breaker. People are in fear of the machine that appears to start be having human-like capabilities. The automated loom didn't just move things around, it had control. It could actually weave. And that led to the automation revolution, if you like, the computer-controlled lathe, and the information revolution, the punch card. At about the same time, electricity. Now, Mary Shelley's Frankenstein, published at the beginning of the 1800s, was animated by mysterious means, basically body parts and pieces of meat that somehow come to life. But 100 years later, after electricity and after mechanization and after automation, Frankenstein gets reimagined as this guy with bolts through his neck who's animated using electricity, he becomes more technological. Quickly followed by this idea of robots. The information revolution, meanwhile, moves to networking. And what happens to the robots? They start to get networked. Think about Skynet from the Terminator, or the artificial intelligence in the Matrix. So you see the golem changing with technology. And what comes after the information revolution? Well, that's the Internet of Things. What is the Internet of Things? The Internet of Things is giving senses to machines via networking. So hang on, we've got these robots and they're networked, and the next thing they can do is sense. That must be it, right? That's the end of the human race. We're kind of done now. Well, let's review. So the Internet of Things is here, it's all around you, you may not realize it, right? In the year 2000, there were barely any digital cameras. Now we ship more than 1 billion a year. And they're becoming more automated. You see facial recognition technology when you upload your images. There's other automation now, trying to understand what else is going on in a picture. You may have seen the thing where the Microsoft technology tries to guess how old you are. So that's one example of networked sensors, adding, if you like, intelligence to the network. Here's another. GPS was not available to the public in the year 2000, was not available in smartphones until after 2005. Now, again, 1 billion units a year. Your phone knows where you are, even if you don't. And those are just phones, right? You're aware of the rise of smartphones. That's not a very insightful observation. There are smartphones everywhere. You see people using them. Some of you are using them right now. But RFID tags, which stands for Radio Frequency Identification Tag, which is a fundamental Internet of Things technology, we ship 1 billion more RFID tags a year than we do smartphones. And we have done for several years. Where are they? Access control cards for buildings, toll tags for the fast lane on the toll road, hotel keys, automation systems, supply chain systems. They're everywhere. You just don't see them. They're tiny. So the Internet of Things is very much here, and it's giving our computer systems the ability to touch, to see, to locate. And we'll see more and more of these ubiquitous wireless network sensor technologies emerge over the next few years, or rather we won't, because they'll just be embedded in devices we use. So does that mean this big, scary artificial intelligence that we see in the movies has arrived? Well, let's review. Are we in the age of Ultron? So for those people who don't know, Ultron is the robot that tries to take over the world in the new Avengers movie. It's just the latest incarnation of the golem, frankly. Well, he's bipedal. He walks on 2 feet. Can we do that? Somewhat. There is, for example, a robot, you can see it online by a company called General Robotics. It's called Atlas. It's designed for safety applications. It's kind of emerging out of prototype right now. It's bipedal. So we can sort of do that. And through the 21st century, we will definitely see bipedal automation become ubiquitous. So yes, we're going to give that a check mark. During the 21st century, that will happen. Sentience, the ability to sense. That's the Internet of Things. Starting now, it's very powerful already. Over the next few decades, that will unfold. So I'll give that a check mark. So that's 2, but there are 10 things on the list. Do we have technology that can set its own goals? No, not even close. What about natural language? Well, somewhat, but we don't really understand the fundamentals of natural language in human beings. So that's really a no. And natural language, by the way, is a prerequisite for creative behavior. You may think that language is so we can communicate with each other. It's actually so we can think. So we can think about how to solve problems. That's what's unique about human beings. We have this creative instinct. And language is what enables it. So without language, you can't have creative machines. A lot of these robot movies, they form alliances with one another, or some kind of group activity going on. We don't have any clue how to represent that automatically. Self-awareness, the instinct to survive and reproduce, no clue. Consciousness, we don't really even know how to define that. Just as the watermill begat Newtonian physics, it wasn't an apple falling on his head. I'm sorry to disabuse you. There was a watermill down the road, and that's one of the things that led to the Newtonian revolution. Just as that happened, so automation is helping us think about cognition. And through the century, we may see a revolution in how we understand human cognition. And that may one day lead to a notion of automated consciousness, but not this century. So the net of this is, even with the Internet of Things, we're scoring 2 out of 10 on the Ultron test here, which is an F. Oh, so you're safe. The robots are not going to take over the world in your lifetime, or your children's lifetime, or your grandchildren's lifetime. So what can we do with the Internet of Things and automation today? And really, by the way, it's just fancy windmills. That's really what it is. We're taking energy and we're controlling it. That's what we're doing. I'm going to give you one example and one benefit of that one example. So here is a self-driving car. And this is kind of what the self-driving car sees. It uses a sensor technology called LiDAR, which is not an acronym. It's a combination of light and radar, and it gives the control system in the vehicle 360-degree vision all the time, basically, for quite a long way. Now, oh my goodness, self-driving cars. Will that be safe? Well, how safe are human-driven cars? The first thing to know is a lot of human-driven cars are actually self-driving cars already, but without the self-driving technology. 3,200 people killed by cars every single day. At least 94%, therefore more than 3,000 of those, due to human, quote-unquote, error. Now, if you're looking at your cell phone, or in one case playing the trumpet while driving, I don't know if we can call that human error. And let's look at some examples of human error, shall we? Here you see the white car making a perfectly normal left turn. That pink rectangle is another car also making a left turn, but you'll notice it's making a left turn by going into the other car's lane. I'm sure none of you have ever had this happen to you. Here's another one. The white car is trying to move forward because, as you can see, it has a green light, but that sort of pointy pink shape is turning right from the wrong lane. And here's an excellent example, and this is very common at night. Here we have our white car traveling along, and these two sort of pink, squarish, rectangle things on the other side of it are vehicles coming in the other direction. Now, if you have a driver's license, you may notice a problem. There's also a median, and the cars coming in the other direction are on the wrong side of it. This stuff kills thousands of people, not every year or every month, but every day. And all these images, by the way, are from the mind of a self-driving car. This is data from a self-driving car. So how do self-driving cars do? Well, let's look at Google. Google so far has done 1.7 million self-driven miles. There have been 11 accidents, all minor, light damage, no injuries, and none of them were caused by the self-driving car. Now, this is not the age of Ultron, this is the age of the fancy windmill, but it's really cool.